Okay, so this is going to show the other formula we want, which is going to be law of cosine. The law of sines formula is really great if you have two side lengths and an angle and you need to find a missing angle, or you have two angles and a side length and you need to find a missing side. Okay, because if we review that really quick, we had sine of A over A equals sine of B over B. These represent side lengths. These represent angles. So if I knew these two angles and I knew this side length, and this side length would have to be opposite of this angle, I could solve for this. Same thing if I had these two side lengths and the angle opposite of this side length, I could use this formula to solve for that angle. But we don't always have that kind of a situation. So for example, if we have this triangle here, we have two side lengths and an angle, we actually could use law of sine, but we're also going to do something else that has law of cosines, which gives us some more options here. So I'm going to take this triangle and turn it into this one here. I'm going to drop a hypotenuse, or a height. And if we talk about this, when we drop that height, we have, and even if we did it here, okay, we would need to know what these side lengths are. So if we think about this, if this whole side length is B, and we call this X, how does this part here, how can I write that? And if we think about this here, if the side length is 20, okay, and I tell you that this part is 7, well, this part has to be 13 because 20 minus 7 is 13. So this is X and this is B. This has to be B minus X will give me this distance here. Okay, so we can do some right triangles here. I'm going to erase my picture right here so I have some room to write. Okay, so if I think about this right triangle right here, there's some relationships I can write because it's a right triangle. So I'm going to use Pythagorean's theorem. So a squared is equal to x squared plus h squared. And again, just like with law of sines, we're kind of looking for some similarities in this one to another equation so we can do some substitution. So over here, we have c squared is equal to h squared plus this quantity squared. Okay, we have some similarities there, so we should be able to write an equation that combines them together. I'm going to deal with this little piece down here for a second. So if we know, if we have b minus x squared, it's that quantity times itself, we can use the distributive property. This times this will be b squared. B times negative x will be negative bx. Negative x times b will be another negative bx. And negative x times negative x will be positive x squared. Okay, if we're thinking about how to deal with this, just think about this for a second. If I have minus 3, okay, so I'm at negative 3, and I subtract 3, well, think about which direction subtraction of whole numbers moves you. If I'm at 10 and I subtract 3, I move back 3. If I'm at 12 and I subtract 3, I move back 3. If I'm at negative 7 and I subtract 3, I move back 3. So if I'm at negative 3 and I move back 3, I'm at negative 6. If we apply that to over here, we're at negative some number, and I got to move back that same number. I've moved back twice of that number. So we will get b squared minus 2bx plus x squared. So I'm going to take this whole thing here. I want to make sure the camera is showing that, so let me tip that down. Yep, it is. Okay. So I'm going to take this whole thing here and replace that up here. So erase that. We have b squared minus 2bx plus x squared. Okay, if we could get both these equations to equal h squared, we can do some substitution. So if I change this problem to say h squared equals, let's see here, a squared minus x squared. Okay, and if I solve for h squared here, h squared will equal, let's see what the easiest way to do this is. C squared minus b squared plus 2bx minus x squared. Okay, and I skipped the whole solution process, but you can show things on both sides and get that. So these two equations are there. Since they both equal h squared, they can both equal each other. So I'm going to erase this down here. Okay, since this is equal to h squared and this is equal to h squared, they are therefore equal to each other. So we can write a squared minus x squared equals c squared minus b squared plus 2bx minus x squared. You can do some simplification. If I add x squared to both sides here, that part becomes 0. Okay. And then, let's see what else I want to do. I'm going to move some things around here just to make things a little bit more workable. So that's gone now. And so is this. Okay, I'm going to add b squared over here. So this is gone. And this now says a squared plus b squared. Okay, and then I'm going to subtract 2bx over here, subtract 2bx over here. So we get the equation c squared equals a squared plus b squared minus 2bx. I'm going to just erase this and rewrite it this way. So c squared equals a squared plus b squared minus 2bx. Okay, the only other thing that I want to do is see if there's any way to write x in terms of a, b, and c. Because right now I have a lot of variables going on, so I want to see what I can do. If we think of x, and this is the law of cosine, so I want to use cosines here. I can actually solve for x using the cosine of c. So if we took the cosine of c, that would be equal to the ratio of x over a. And if we solve for x in this equation, x would be equal to a times cosine of c. So I can go ahead and substitute this information in here. So I'm going to get the equation c squared equals a squared plus b squared, which is what I had before, minus 2b, and then if I substitute in x here, a times cosine c. And then I'm just going to rearrange this and write this nicely. So this is the law of cosine. C squared equals a squared plus b squared minus 2, and I'm just going to switch the order of those, a b times cosine c. Okay, then the question is, what did I just figure out? Okay, so let's look back at the picture, and I'm going to erase all my extra stuff so we can just kind of focus on what I have here. What is C? What is A? What is B? A, B, and this C here. Well, C is a side length. A is a side length. B is a side length. So are those. And this is an angle. Okay? So that means that if I'm given a triangle, and I give myself a side length C, so we'll say 7, and I give myself a side length for A, so we'll say 8, and I give myself a side length, let's leave this one the same, okay? So we'll just leave that as B. And then I have an angle, and this is angle C. Now, the only thing that matters here is if I chose this side length C, angle C has to be opposite. So let's say I give myself 30 degrees. Then if I have a triangle like this, I have enough information to plug in here and solve for B. Okay? Same thing too, and this is the triangle that we had in class when we did our toolbox. I believe this was 10, 7, and 8. Okay, I have a side length, so I'll call that C squared, side length 8, side length here. Okay, if I solve this, I'll be able to find the angle that's opposite the side that I chose for C. So if I chose 10 for C, when I do this, this angle will be C. I'll be able to find this angle here. Once I have that angle, then I have enough information. Well, I have two sides and an angle. I can use law of sines to help me find another angle, or I could complete this process again, but maybe 7 represents the C this time. This is the A, this is the B, and then when I find the capital C, that'll be over here, okay? So that's kind of what we're looking at. The hardest thing with law of sines and cosines is deciding what kind of triangles they fit for. So just keep in mind that when we're doing our side lengths, if this is A, this has to be A. If this is B, this is B. And if this is C, this is C. And it's up to you to decide what angles you label what.